Okay friends, in the second part, let us solve some more examples on lines in space. So let us solve an example here. A line passes through point 2 minus 3 5 and makes equal angles with the axis. With the coordinate axis, we are supposed to find the perpendicular distance of the point 1 minus 2 3 from this line. Okay. There are two methods of solving this sum. In the first method, we will find the coordinates of foot of perpendicular and then use distance formula. And in second method, we will directly use a formula which I will explain later. But the first thing to do is to find the equation of this line. When the line makes equal angles with the axis, so the direction cosines of the line are same. Now we know L square plus m square plus n square is equal to 1, and that gives me that is 3L square is equal to 1, and that gives me L as plus or minus 1 by root 3. I will take only the positive sign, so the direction cosines will be, since all of them are same, all of them will be 1 by root 3. 1 by root 3, 1 by root 3, 1 by root 3. Now we are interested in direction ratios. So let us multiply throughout by root 3. If we multiply throughout by root 3, remember direction ratios are numbers proportional to direction cosines. We can multiply each direction cosine by any number. Let me multiply by root 3 and I will get the direction ratios as 1, 1 and 1. So what will be the equation of line? The equation of line, it is passing through 2 minus 3 5. So the equation of line will be x minus 2 upon 1 equal to lambda. This will be the first step. We have obtained the equation of line. Now let us go ahead and draw the illustrative figure. Okay, so what is the situation here? We have a point here, say P, which is 1 minus 2 3. This is a line. This line, it has a vector along the line as I plus j plus k. I write it as 1 1 1, and this is M. Our first job is to find coordinates of M. So you can see that this line, we can get the x coordinate, y coordinate and z coordinate. They represent coordinates of any point, so they can also represent coordinates of M. So what will be the coordinates of M here? See carefully. X minus 2 upon 1 is lambda, that gives you x as lambda plus 2. The y coordinate will be lambda minus 3, and the z coordinate will be lambda plus 5. So these are the coordinates of M. These are the coordinates of P. So what is Pm bar? Pm bar will be m bar minus p bar. So lambda plus 2 minus 1, that is lambda plus 1, lambda minus 3 minus minus 2, lambda minus 1, and lambda plus 5 minus 3, lambda plus 2. So this is Pm bar. And look at the figure. This is PM bar. This is PM bar and B bar is like this. So PM bar and B bar are at right angles. So dot product of will be 0. So this is B bar I plus J plus K and this is PM bar. So the dot product will be lambda plus 1 into 1, lambda minus 1 into 1 and lambda plus 2 into 1. That will be 0 and that gives me 3 lambda equal to minus 2 or lambda as minus 2 by 3. We can substitute this value of lambda in M and we'll get coordinates of M. So that is the next step that we will do. Let us find the coordinates of M with lambda as minus 2 by 3. So what do we get here? M as 3 to the 6 minus 2. So 4 by 3 minus 9 minus 2 minus 11 by 3 and 15 minus 2. That is, our job is done. This is M, this is P. Just use the distance formula to find the length PM. So PM will be square root of 4 by 3 minus 1 whole square plus minus minus 2, so plus 2, 13 by 3 minus 3. How much that turns out to be? 1 by 3 ka whole square plus 3 to the 6, so minus 11 plus 6 is minus 5. Thirteen minus 9 is 4. And that gives me 1 by 9 plus 25 by 9 plus 16 by 9. Please do the calculation and get the answer. This gives me same as root 14 by 3. So this is our final answer. So what we did here is we found the coordinates of foot of perpendicular and then use the distance formula to find the perpendicular distance. Now there is one more easy step. If they ask you to just find perpendicular distance, then you will use a formula which we used to find the distance between two parallel lines. So let us use that alternative method to find the distance. So what we have here is point P. Let us take this as A1, which is 1, minus 2, 3. This is a line. There is any other point A2 on this line, which we know as 2, minus 3, 5. And we already computed the vector along the line B bar as I plus j plus k. The formula for the perpendicular distance, this distance, is given by, I hope you remember, we had done it last time, A2 bar minus A1 bar cross B bar upon mod B bar. So this is the formula that we will use. So let us compute first A2 bar minus A1 bar. A2 minus A1 is 2 minus 1, so I bar, minus 3 plus 2, and 5 minus 3. See again, 2 minus 1 is 1, minus 3 minus 2, minus 3 plus 2, which is minus 1, 5 minus 3 is 2. So this is A2 minus A1, this is B bar. So let us compute this. And that will be I, j, k, 1, minus 1, 2, and 1, 1, 1. Okay, so what do we get? We get I bar into minus 1, minus 2, so minus 3, minus j bar into 1 minus 2, minus 1, plus k bar into 1 minus minus 1, that will be 2. So this is A2 minus A1 cross B bar. Fine. Now we need to find the magnitude of A2 minus A1 cross B bar. So we are going to fill it in the formula. What is the magnitude of A2 minus A1 cross B bar? It is 3 square, 9, 1 square which is 1, 2 square which is 4, upon what is mod of B? B is I plus j plus k. So magnitude will be root of 1 square plus 1 square plus 1 square. And what is the answer of this? The answer of this will be root of 15 by 3. Same answer as we got from the previous exercise, but this is the quicker method. In CET you can use this method if they ask you the perpendicular distance of a point from a line, where there is no need to find the coordinates of foot of perpendicular. So this is one example. Let us go ahead with the second example. I hope you have understood this clearly. You can memorize this formula for perpendicular distance between a point and a line. Now we'll do image of a point in a line. That is the second example. Find the image of 1, 2, 3 point in the line x upon 2 equal to y minus 1 upon 3 equal to z minus 1 upon 3. Let us take this as lambda. Now please see the situation. This is a line. This is a point, say P. Excuse me. We want to find the image. Means if we draw perpendicular and if image of this point P is here, so this is M and this is N. N is the image of P. Then PM and MN will be same, and this line will be at right angles. So all we have to do is, just as the previous exercise, find the coordinates of M and then use the midpoint formula to find the coordinates of N. But let us do first thing first. Let us find the coordinates of M first. What is the vector along the line? The vector along the line is 2, 3, 3. This is the vector along the line. Let us find the coordinates of point M from this formula. So M will have coordinates 2 lambda, 3 lambda plus 1, 3 lambda plus 1. This is M and this is P. So what is PM bar now? Again M bar minus P bar. Again I will write it only in terms of coordinates. So 2 lambda minus 1, 3 lambda plus 1 minus 2, and 3 lambda plus 1 minus 3. This is PM bar. As you know, PM bar and this B bar are at right angles, so their dot product will be 0. So that will give me the value of lambda. So 2 times let's see what we get. We get 22 lambda equal to 11. That gives me lambda as half. Now if you put lambda equal to half in the coordinates of M here, I will get the value of coordinates of M. So let us do that. I am going to put now lambda equal to 1 by 2. Put lambda equal to 1 by 2. And that gives me the coordinates of M as 1, 5 by 2, 5 by 2. So 1, 5 by 2, 5 by 2 are the coordinates of point M. Now let us find the image. Image means we want to find the coordinates of N. So what is the situation? Let me draw only the 3 points. I'll just take N as X, Y, Z, and these two are same. So by midpoint formula, 1 will be 1 plus X upon 2. That gives me X as 1. 5 by 2 will be Y plus 2 upon 2. that gives me y as 3, and this 5 by 2 will be, you can see, z plus 3 upon 2, and that gives me z as 2. So what is the image? The image of the point is coming as 1, 3, 2. So this is the image of point P in the line. Let's do the third example, that is point of intersection of two lines. Point of intersection of two lines. Okay, what are the lines given? The lines given are x minus 5 upon 3, this is one line. Let me take the parameter as lambda. The second line is, sorry, let us take this as mu. Let us find x, y and z coordinates of both these lines. What is the x coordinate of first line? 3 lambda plus 5. What is the x coordinate of this line? Minus 3 mu minus 3. Now since the point of intersection means both the points should be same, so the first equation I will get by equating the x coordinates. So I get one equation, 3 lambda plus 5, and that gives me 3 lambda plus 3 mu equal to minus 8. This is the first equation. Now let us compute the y coordinate. What is the y coordinate of first line? Minus lambda plus 7. And what is the y coordinate of second line? 2 mu plus 3. Again equate this. And you will get the equation minus lambda minus 2 mu equal to minus 4. Just solve these two equations simultaneously. You will get the value of lambda or mu. Once you get the value of lambda, you can substitute and you will get the coordinates of x, y and z, which are the coordinates of point of intersection. So I think I leave this exercise to you. You can easily do that. If you want to verify your answer, then you can also find a z coordinate and check if the equations are consistent, but there is no need. You can pick up any two points, either x and y or x and z, find two equations, solve them simultaneously to get the value of lambda or mu, back substitute to get the coordinates. So I think you can do this exercise on your own. So please do that. Now let us solve a few more practice examples. I think we have solved most of the problems. So there is no need to go for any other problems. I'm just looking for any practice sums to give you. Now here is one a little complicated sum. Let's see if we are able to solve this. It is a little complicated. Find the equation of line which is passing through 2, 3, 4 and which is perpendicular to x-axis and intersecting the line x equal to y equal to z. See the sum. We are supposed to find the equation of line which is passing through the point 2, 3, 4, which is perpendicular to x-axis and which intersects the line x equal to y equal to z. Now first see the meaning of perpendicular to x-axis. If a line is perpendicular to x-axis and if I pick up any 2 points, they will have the same x coordinate. Y coordinates may be different, z coordinate may be different, but the x coordinate will be same. So when we take the direction ratios, a will cancel. So in the direction ratios, the first ratio will always be 0. The other two I don't know, I can take it as say a and b. So direction ratios of a line which is perpendicular to x-axis will be 0, a, b. Suppose it was perpendicular to y-axis, then the y coordinate will have been 0. If the line was perpendicular to z-axis, then this would have been 0. So direction ratios of a line which is perpendicular to x-axis are 0, a and b. Now it passes through 2, 3, 4. So what can be the equation of line? Let us see. The equation of required line will be x minus 2 upon 0, y minus 3 upon a, z minus 4 upon b. It intersects line x equal to y equal to z. X equal to y equal to z can be written as x minus 0 upon 1 now I have told you in the first chapter part 1 that if two lines are intersecting, then they are always coplanar. So since these two lines are intersecting, the lines are coplanar. So we are going to use the funda of scalar triple product as 0. Let me draw the situation for you. In this plane we have these two lines, so there is a point 2, 3, 4, say a1, there is another point 0, 0, 0, there is a vector 0, a, b, and there is another vector 1, 1, 1. So the vector a1 o bar, this one and this one, their triple product will be 0. I just take this vector as p bar and take this vector as q bar. So the scalar triple product of OA1, p bar and q bar will be 0. Let us do that. OA1 will be obviously 2, 3, 4. Then we can have, order is not important, 1, 1, 1 and then 0 AB will be 0. Let us find now the equation. So this is 2 times b minus a minus 3 times b minus 0 plus 4 times a minus 0. So 2b minus 3b is minus b. Therefore, you have a situation 2a equal to b. Now we are interested in finding direction ratios. So you can take any arbitrary value. If b is 1, if b is 2, then a will be 1. You can put a equal to 1, you will get b equal to 2. So a is 1 and b is 2. So you can substitute here a as 1, you can substitute here b as 2, and that is your final answer. The equation of line is x minus 2 upon 0 equal to y minus 3 upon 1 equal to z minus 4 upon 2. So just remember, if the line is perpendicular to x-axis, in the direction ratios, the first direction ratio that associates with x-axis will be 0. That's all. In the next lecture, we will talk about planes, and then we have to consider lines and planes together. So it's going to be a lot of work for us.